Good morning, Algebra 2. We're going to go over angles of rotation and some really important information if you proceed on to trig. So, angles can be formed two different ways. So I have two categories written down, positive angles and negative angles. Now, both angles start at the same place. Notice both angles. I'm on the positive side of the x-axis. Now, a positive angle is formed when you're starting at the x-axis and you move counterclockwise, which is a very long word. But positive angles are formed counterclockwise from the positive side of the x-axis. Now, negative angles, you start from the same place, from the positive side of the x-axis, but you rotate clockwise. So you start at the same place, but you end somewhere different. Now we need to go over what the different sides of an angle is called. So when I form an angle, so let's say I say 130 degrees. So 130 degrees, right, I would start here. There would be 90, right? I would need to go another 40 degrees. So let's estimate that my angle is here. Now this side that I formed is called the side that the angle forms is called the terminal side. Okay, and that is the side that is formed from our angle. So if this angle represents 130 degrees, okay, and notice because it's positive 130 degrees, I rotated counterclockwise. Okay, so that's super important. If I said draw negative 270 degrees, we start at our x-axis. Now I know each of these is a 90-degree angle. This is my x-axis, here's y. So now because it's negative, I would draw it moving clockwise. So here's 90, 180, 270. And so 270 is kind of crazy because the terminal side happens to be our x-axis. So that is, I should label, this is our terminal side, and over here that would be terminal side. So now let's talk about coterminal angles. Coterminal means they share the same terminal side, and it usually involves rotations of 360. So, for example, if I asked you to draw 30 degrees, I know that because it's positive, I would move counterclockwise. So here's 30 degrees. And I'm going to highlight. There's my terminal side right here. Now, 30 degrees and 390 degrees share the same terminal side, and I'll demonstrate that. So here is 30, but 390, starting same place, there would be 360. 360 plus another 30 degrees is 390. So 30 plus 360 equals 390. So the angle of 30 and 390, they share the same terminal side, okay? They both have this side here. Now, the same would be true with 30 and negative 330. So let's go over that. Negative would mean that starting from here, I would go clockwise. So here's 180, 270. And then I would go 60 more degrees, and I would land up in the same place because 30 minus 360 is negative 330. So all of these angles share the same terminal side. So we would say they are coterminal because they all put us in the exact same place. So let's go over that and do the first few on your lesson practice. Lesson practice is on page 403. So for parts A, B, and C, they'd like us to draw, and you're just doing an estimate. Now remember, I didn't cover this earlier because I just figured a full circle is 360 degrees. And I know that this here is 180, right? And this here is 180. So I also know straight line is 180. Also, we know that each quadrant is 90. So that's just some review for when you draw your angles. So part A would like us to draw the angle of 60 degrees. You can use a protractor, but what's really important is they want you to remember where positive and negative angles and what direction they are. So here is my x and y axes. Here's x, here's y. Now I know that this right here is 90 degrees. So, and this is a positive angle. So starting from here, right, I know it's going to be in this quadrant because I'm moving counterclockwise. So if this is 90, I'm going to guess here's 30. It should be 2/3 of the way. There would be 60 degrees. Okay, so that would be your little picture. And there's my terminal side highlighted in yellow. Part B would like us to draw negative 120 degrees. Now remember, negative angles mean that I'm going to go clockwise. So starting on the positive side of the x-axis, I'm going 120 degrees. Now I know if I go all the way to here, that would be 180. Right? And so I need to go 60 degrees less than that is 120. But it's got to be more than 90. So I know it's more than 90. In fact, it's 30 degrees more. So I'm going to put it here. I'm estimating you could use a protractor if you prefer. But I went negative 90 going clockwise. This is 60 degrees going counterclockwise. Okay? Pretty simple. Let's try now part C. They'd like us to draw 385 degrees. Now when I see that, I notice that one, it's positive, so I'm going counterclockwise. But also I know that's more than a full circle. So 385 minus 360 equals 25. So I'm going to do a full circle and then about 25 degrees more. So let's draw that. Find your starting place. So let's start simple. We're going counterclockwise 360, so full circle. And then let's estimate 25 degrees. So that would put me in quadrant 1 because I went a full circle and then 25 degrees more. Now, moving on. That was drawing. For the next part, I'm actually I don't know if it'll come through very well. They want us to find the measure of one positive and one negative coterminal angle for the following. So part D, they gave me 94 degrees. So to find a positive, I would add 360. To find a negative, I would subtract 360. Right? Because I would do a full rotation from each one to find a coterminal angle. So 94 plus 360, whoops, I didn't mean to put that decimal there, gives me 454 degrees. My bad. 94 minus 360 gives me negative 266 degrees. So that is one positive coterminal angle, one negative coterminal angle. So now let's move on to part E. I'm going to go ahead and write it down, and then I'd like you to try at least the positive one. So 730 plus 360, 730 minus 360, minus 360, minus, and we'll talk about why I'm having to do that. So let's start with the 730 plus 360 gives me 1090. Okay. Now, a negative, I have to keep subtracting 360 till I get a negative. So that's positive 370 minus 360, positive 10 minus 360. I finally got a negative coterminal angle. I just kept subtracting full rotations, the 360 degrees. Now, the next part of our notes has to do with reference angles. And a reference angle is an angle formed by the terminal side and the x-axis. And so I'm going to show you an example of one. So if I said 110 degrees, so that's positive. So here's 90. Let's say this is 110. So my reference angle is the angle formed between my terminal side and my x-axis. So they're looking for this angle here. Right? This is my x-axis. That right there is my terminal side. So this right here is my reference angle. So any guess on how I would calculate my reference angle? Well, I know a straight line is 180. So 180 minus 110 would give me a reference angle of 70 degrees. So 70 degrees is the reference angle. Now, let's say another example. Negative 135 degrees. Okay, so now in this case, I am negative. So the only difference is instead of going counterclockwise, I'm going clockwise. And this is 90, so I'm going to go another 45 because 135 minus 90 is 45. So here is negative 135 degrees. So here's my terminal side. Here's my x-axis. I'm looking for this angle here. Okay. Now you don't have to account for the fact that it is negative. We're simply looking for the distance between the 135 and the 180. So I'm going to simply take 180 minus 135, and I have the distance here right here is 45 degrees. Okay, so it's just the difference. Even though I know this is negative, we're just finding the difference between the terminal side and the x-axis. Okay, so back to our lesson practice. They'd like us to find the reference angles for part F, G, and H. So part F, 115 degrees. You don't have to draw a picture, but it's good practice. That would be here. So 180 minus 115, right? I'm looking for this angle here. And I'm drawing a picture because for those of you who move on to Trig, we're going to be doing a lot of this angle, reference angle thing. And so 185 minus 115, I believe that gives us 65 degrees. 65, yeah. As our reference angle. Part G, 200 degrees. Okay, that'd be 180, and then right here. Right, there's 200 degrees. I'm looking for the angle formed right here. So 200, right, minus the straight line gives me a reference angle of 20 degrees. All right, next, part H, negative 145 degrees. So I just like to draw pictures. Here is negative, so it puts me here. And again, we're looking for this angle formed between our terminal side and the x-axis. So 180 minus 145, doesn't matter that it was negative, it just tells you where it's at, gives me 35 degrees. That's the difference between my terminal side and the x-axis. Notice I'm always using 180, and that is because a straight line, or the x-axis, right, this is x, and the x-axis is a straight line, which makes 180 degrees. Okay, last one that we're going to do, and it is seen on test and homework, is finding, and I'll just turn the page, finding all 6 trig ratios from a point. So I'm going to do an example. So let's say I tell you my point is at 3, negative 4. And I want all 3 trig ratios. So the first thing I'm going to do is draw a picture. So positive 3, negative 4 puts me here. And I went positive 3 units to the right, and I went 4 units down. And so I'm labeling those pieces, and this was negative 4. I went positive 3 because x is 3, y is negative 4. And that forms this nice triangle. Now, if I want my trig ratios, I need opposite, adjacent, and hypotenuse. So I'm going to need to find my hypotenuse, which is here. Right, this is my hypotenuse. And I would do that from 3 squared plus negative 4 squared equals my hypotenuse squared. So that gives me 9 plus 16 equals h squared. So 25 equals h squared. So my hypotenuse is 5. So I'm going to change this. I now know that this side here is 5. So let's go over SOHCAHTOA. And opposite of sine is cosecant. Opposite of cosine is secant, the reciprocal. And opposite of tangent is cotangent. So let's pretend the angle that we're referencing is this angle here, theta. So the sine of theta would be opposite, which would be negative 4, over hypotenuse. Hypotenuse is always positive. So I drew a picture. Number 2, I found hypotenuse. And then 3, write your trig ratios. And simplify if possible. So the sine of theta equals negative 4 over my hypotenuse of 5. The cosine of theta is adjacent over hypotenuse. The tangent of theta would be opposite over adjacent. So there's the first 3. Now I'm going to find my reciprocal functions. So the cosecant of theta should be the reciprocal of sine, so negative 5 over 4. The secant of theta is the reciprocal of cosine, so 5 over 3. The cotangent of theta is the reciprocal of tangent. So those are the 6 trig functions formed by the triangle of that point. So last part of our lesson practice is part I. We're not going to do J. And part I, they've told us to use P point negative 15 and negative 8. Now, I like to draw a picture. It just helps me visually. So I've got X is negative 15. So let's say I put that here. Y is negative 8. So here's my point. Right, I went to the left negative 15 and down 8. So here's my point. And I'm going to form this triangle. So here's theta, There's my 90 degrees. Notice I'm still going to have to find my hypotenuse. So we drew a picture. We've got our triangle, right? This is x, this is y. So maybe instead of x right here, I'll use z. So -8 squared plus -15 squared equals z squared. Now, please, if you mess up right here, I'm just going to cry. A negative number squared, right, is positive because a negative times a negative. So you could just write 8 squared plus 15 squared equals z squared. So I'm going to enter that in my calculator. 8 squared plus 15 squared, I get 289 equals z squared, square root, z equals the square root of 289, I believe is 17, yes. So now I've got all my sides. So now I'm going to do the sine of theta, the cosine of theta, the tangent of theta. That's what we call this little angle, theta, a Greek symbol. Then I'm going to find the cosecant of theta, the secant of theta, and the cotangent of theta. Start with your original functions first. So the sine of theta would be opposite, which is a -8. Remember, hypotenuse is always positive, so over 17. The cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And I do want you to simplify. So that's a positive, right? A negative divided by a negative is a positive. So here is the sine of theta, the cosine of theta, the tangent of theta. Now you can write their reciprocals. So this is -17 over 8. I'm just flipping it over. This is -17 over 15. This is 15 over 8. So that's why I find my 3 original trig functions first, and then I write the reciprocal. So that covers this section. We are going to skip part J for your homework. Skip numbers 1 and 2, 11, 17, 18, 24, 29, and 30. You're welcome.